Hello friends, welcome to the Tech Granth. Today's system design is regarding distributed logging, and I got a few review comment that you guys want me to do a system design on this distributed logging, and it has become pretty common. Reason being, everyone is moving from a monolithic architecture to a microservice architecture, and in microservice architecture, this becomes very useful, and you need to have a way in which you can basically trace your log for any particular flow from end to end. So let's jump into the system design for distributed logging. The requirement that we will be talking about here are we should have a centralized logging capability that otherwise it does not make any sense that you go to each of the microservice and look at the log and then trace your bug. So that is why the logging should be centralized. The log tracing also should be centralized. It means that other than the log being in one place, your UI or the visual that you should be using or the mechanism that you should be using for tracing your log or to find the flow from end to end, that also should be centralized. The next requirement is that the report that you should be able to generate, so there should be multiple ways in which you should be able to generate your report, and one case is like it should be specific to one of the error. So you should have a report which will tell what all 404 error that you got over a period of like 1 hour or a day or so. So that kind of reporting capability should be there as part of your system. And the last one is that your system should be able to give an alert, like if some fatal error has happened or something has been captured in the log which can cause a fatal error. So based on those error, an alert should be raised in some UI or maybe a mail, or if you are using a common chat kind of system, then maybe bot chat should be there which will give you an alert saying that this is the error that has been encountered as part of the whole process. So these are the fundamental requirement that we will cover as part of the distributed logging. So if you were using or you are using a monolithic application, the way you will trace down your log will be pretty simple. There will be one log for the whole monolithic application, and you can just go to that particular log and see what is the error. If some error has come, then you can just browse down that particular log and you can come to know what is the error that you are getting and from which system you are getting the error, because there will be just one system which will be running for you. But if you consider a system like this where you have so many services, these are all S1, S2, S3, these are all microservices, and some of them has their own database, and all the microservices are dependent on each other. So if a call comes to S1, it may go to S4, from S4 it can go to S6, and from S6 it will go back to S4, from S4 to S1. Similarly, if you see here, from S3 it can go to S5, it can also go to S4, then from S4 to S6, or it can directly go to S6 and come back to S3. So these are related to each other, and if suppose I have an error which came at S6 and that session originated from S3, not from S1, so to trace back that particular session, that what was the request that was started or originated from S3 that got the error, it will be little tough if I have to go to this particular service and look at the log. Now the second challenge in case of microservice will be, even though here it looks like one service, but it will be more than one service. So there will be multiple instance of these service that will be running. So each of these microservice will have multiple instances that will be running. So for example, if it has been deployed in any cloud application, so on a cloud platform, so in the same place or the same, you can say, pool or the same location where your cloud has been hosted, so there at least two instance or three instance of the same application will be running. It can happen that you deploy your application across multiple pool, like one can be active, other can be DR or passive. So and on each of them multiple instance of the same services are running, so you can end up having like at least four service that will be running for your application. And there can be a load balancer here just before your service. So there can be a load balancer or a service discovery kind of thing which will route the request to one of these service. Now in this particular scenario, what will happen is that for the same service S1, the request can come from any of the instance that is present. So you have to figure out that whether that one instance is giving the error or the error is across all the instances. That kind of scenario can originate. So that is why this distributed logging becomes really important to handle all these kind of scenario. So a simple design for this is that what we can do is, rather than logging the service in the same place where the service is running, you log it in a distributed queue. So you use RabbitMQ or Kafka or any queuing mechanism. Kafka becomes important because most of the product will already be using Kafka, where you have microservice kind of architecture. So you have a distributed queue which is already present with you. So you can just reuse one of the topic or few of the topics there. And what you can do here is that from each of the service, you can just push the log to this particular queue. Once the log has been pushed here, and what there are few details that you need to push into this particular log, and those details are like correlation ID or some ID which can be moved from one service to another service. For example, if my request originated from one of the instance of S1, so that ID, that unique ID, should be passed on to S4 for the same request. From S4 it has to be passed on to S6 also. So when you put that particular value in the queue, so if there is any service that is listening to the queue, it will be able to resolve the all the log that is present as part of that particular correlation ID or that unique ID. On top of that, what you can do is you can also add some more context to your request, or from the request you can pick up some of the context, like what kind of request was there, what service called it. You should not pick up the sensitive data, but anything that is related to a call, that what actually that call was trying to achieve, so a descriptive kind of thing. So you can just pick it up and put it in the queue. The same thing can be done for S2, S3, S4 and S5 as well, or whatever service that you have. Now on the other side, you can have some service that will be running, and these service will be specific to your logging. So these service you have to create for your logging purpose. So you can have a log aggregator service which will be listening to the queue. Whenever a new log has been written to the queue, it can just pick it up. It can do some filtration on that particular log, like okay, this log belongs to this category, this log belongs to this server, and based on that it can structure that log a little bit and it can put it in one of the database. So this database can be a MySQL cluster here, or if you have to run some analytics, I'm not sure whether that will be a good use case, but in a general scenario you can use a MySQL database here, where you will store the data for past few days, and all the relevant data that you want, you can store it, and at a later point in time you can archive that data also. So that will be the use of log aggregation service. You can also have a service like error aggregation, which will pick up only those message from the queue which are relevant to error, like a 404 401 kind of error. So you pick only those message as part of this particular service and store them, basically structure them. This is an extension of this uh, log aggregation service itself, but it can be made separate also. So you pick up all the error messages and aggregate them, because at the end of a day, a week or a month, you can come up with a report saying that in general you are getting so much of 404 error. So you can come up with some solution that why those errors are coming. Is it because of the problem in your system, or is it because some authentications are failing from one particular reason itself? So is it because of some spam or something like that? So that can be one useful scenario when you use error aggregation. And the last one is for your alert service. So this will again listen to this particular queue, and this is again an extension of the above service. And what this service will do is, if there is a fatal error, it will immediately, it can send a notification as email or chatbot, or maybe if you have some UI or some monitoring tool, it can basically send that alert to the monitoring tool. So these all will have its own database. This can be part of the same MySQL cluster, or it can be like a small database, just different service. That depends totally on the your requirement, and you can basically separate these. You can keep all of them as same also. And finally, on top of this particular database, you can have some visualization tool like Grafana. So what this tool will do is it will give you a very beautiful UI, and it will give you query kind of system, or you can basically whatever error you have got here, you have already made it into structured data and you have put it into the database, so you can pull the data in a graphical format or a pie chart or all those beautification that can be done as part of the visualization tool. So that way you will have a complete structure where you have, or a complete system which can be used for going through your log, finding error, or basically running any actuator kind of thing, or you can say a health check kind of thing, so that you are aware what all issue is happening in your system. Now this is one design that you can come up with, and this is like a preferred way if you ask me. But there is another way in which you can come up with this system, and that is that kind of design is how Splunk works, or maybe you can think of like how Kibana also work and all. So for that, what you can do is, rather than having a queue here, what what can be done is each microservice can dump their log in one database. So this will be one database, and this database you can call like a log aggregator database, and this will be basically, this database should be it should be connected to an Elasticsearch database also. And on top of the Elasticsearch database, you can put Kibana kind of tool. So Kibana in relation with Elasticsearch, it will also give you a good visualization tool, and you will be able to basically do fuzzy search on that, and you should be able to get whatever the desired result, or you can basically index that search thanks to Kibana and the Elasticsearch. And in fact, Splunk also works in the similar manner, so it will index the file. It does not use any database for storing and all. So that is another approach that you can take. Now the question comes here is that how you can maintain all these correlation ID and pass it on from one microservice to another microservice. So if you're using Java and Spring, so there your answer is this Sluth. So you can use Spring Cloud Sluth. In this, it can work in combination with Zipkin server. So what it will do is, if you see the example here, this has been taken from the Spring Cloud site itself, and I am sure that those who are using other language, they will also have some framework like this, but Spring provides out of the box implementation for this Sluth service. And what it will do is that you can basically import this jar into your all your microservices, and you have to give the uh, path of the Zipkin server, or this can be integrated. This can also get integrated with your Kafka or the RabbitMQ, whatever is present. Even it can integrate with the Logstash. So if you are thinking about designing something like a Splunk, so this will get integrated with that kind of system as well. And what it will do is, for your each log, it will add some metadata to the log, something like this, saying that this log is coming from service 1, and the correlation ID, in this case it will be a span ID. So the span ID is something like this. So you can basically, from your visualization tool, you can go and search for one of the span ID, and in your visualization tool you will get the complete flow of that particular ID. So you will, if there is any issue in between, then you will come to know that this was the request from which user. Now this kind of scenario is really important, and it is very useful in a case where you are running a payment kind of system, or a system where you cannot go back to your user and tell that can you do the transaction again so that I can track the log. No. So for all those kind of situation, you can basically depend on this service, and it will basically help you in finding your log or the bug from end to end for each of the requests that is present. So this one is a pretty simple design, and the code for writing this Sluth will be very simple because it is out of the box. You just import the jar and do some configuration, and you will be good to go. So that is how I felt that this kind of system can be designed. Do let me know in the comment section how you designed this particular system, and what all other benefit that can be added as part of the this particular distributed logging system. So that's it for this video. Thanks for watching. See you in the next one. Bye, take care.